All right, so now that you've had a chance to try the graph, we're going to go ahead and we're going to try to solve, again, and graph this particular quadratic equation. So the first thing you should have done was you should have set both of these equal to 0, both factors equal to 0. X minus 3 equals 0, x plus 1 equals 0. Now we solve. This one, you should have added 3 to both sides, so x is equal to 0 plus 3, which is 3. As a point, the x-intercept, it would look like 3, 0. This one, you should have subtracted 1 from both sides. The 1s would cancel, and 0 minus 1 is negative 1. So as a point, this one would have looked like negative 1, comma 0. From here, what you should have done is you should have found the average of your zeros to help you find the vertex. So here we go. Finding the vertex, the two zeros were 3 and negative 1. So we're going to add 3 plus that negative 1. And because there's two numbers, we divide by 2. 3 plus negative 1 is equal to 2. And 2 divided by 2 is equal to 1. So the x value of our vertex is 1. Now we plug it back into here to find the y value. So y equals the x minus 3 times the x plus 1. We put the 1 into both of these. So y equals 1 minus 3 times 1 plus 1. And we'll clean it up. You could have put that in the calculator. I'm just working this out longhand. That's negative 2 times 1 plus 1 was 2. And negative 2 times 2 is negative 4. So when x is 1, y is negative 4. So that is the middle part of my table. So here's my x, here's my y. The middle part of my table, I should have 1, negative 4. Now we go to our calculator. Remember, we're going to pick two numbers to the left and two numbers to the right of our vertex. Go to your table function and edit. And you're going to have to clear out your function that you see there. And we put in the one up here, that x minus 3 times x plus 1. Push enter a bunch of times. Let's go to where we have x is negative 1. We get a 0. When it's 0, it's negative 3. And that should repeat on both sides of the vertex, which it does here with the 2 and with the 3. So that's the table you should have created. And now you plot your points. So negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. And again, make sure that it looks like a nice, clean graph where you're curving the parabola at the bottom, no points at the bottom. This graph almost looks exactly the same as this one right here, just a little bit more shifted over. So, you now have learned how to graph in intercept form. So the last thing that you need to learn for this lesson is just how to take some of this information and find some of the characteristics of the function. So what we're going to do is we're going to extend both of these graphs that you just drew, and we're going to find the characteristics listed here based on these graphs. When we look for the domain, remember that's the set of x's that the graph can be. Since this is a parabola forever traveling to the left and forever traveling to the right, x can be any value, because all the way to the left is negative infinity, and then the graph goes all the way to the right forever, which is positive infinity. So our domain is negative infinity to positive infinity. That will always be true for a parabola. That is facing up or down like we've been learning how to graph. The range is a little different. Remember, the range is the lowest y value to the highest y value. Look at the lowest y value. The smallest y value is right here where y is negative 4. The graph never goes past where y is negative 4. So negative 4 is the lowest value it can possibly be. And since it can actually be negative 4, don't forget to put the square bracket. Then you say it goes from negative 4 to all the way up here forever, which is positive infinity. Don't forget, since it's approaching infinity, you'll use the curve bracket. The vertex. We already found the vertex. We had to find that to graph it. So just find your vertex, which is in the middle of your table here. It's the place where that point actually changes, or it's the point where the graph changes direction. So it's at 2, negative 4. The axis of symmetry is that invisible line here that would cut the parabola in half. So what's that line, the equation? Remember, you always got to state it as x equals. And what's that value? X equals 2. We get that from our vertex. The zeros, that's your x-intercept. Where did this cross the x-axis? Well, it crossed the x-axis right here at 0, 0. And it crossed the x-axis here at 4, 0. But you, again, can confirm that by looking up here, right up there when we found the zeros before, when we first solved for our factors. And finally, the y-intercept. Where does this graph cross the y-axis? It goes across the y-axis right here at 0, 0. So now, as your final problem to try, I want you to try finding the characteristics here for the graph you drew right here. So you're now going to find these characteristics: domain, range, vertex, axis of symmetry, zeros, and y-intercept. Same as what we just did, but now you're going to do it for this graph that you see. When you're finished, go ahead and watch the final video that goes over those notes.